Hi, welcome to Moo Moo Math. Today we're going to learn how to use half angle formulas. So the first section we're just going to learn where they come from, how to evaluate, and the second part we're going to learn how to solve. So here are our half angle formulas we're going to work with. We have the sine of a half angle is equal to plus or minus the square root of the whole quantity, all under the radical, 1 minus cosine u all over 2. Cosine's half angle is equal to positive or negative the square root of 1 plus cosine u all over 2. All this quantity is under the radical. Now, how do you know whether to evaluate as a positive or negative? Well, it depends on where the original angle falls. So wherever this angle, the sine of this angle falls, or the cosine of the original angle falls, that tells us our signs. So let's go over those signs very quickly. Okay, sine is positive. I'm going to write here. Sine is positive in quadrants 1 and 2. Sine is negative in 3 and 4 because remember, sine is your up direction or down direction. Cosine is positive in quadrants 1 and 4, and it's negative in quadrants 2 and 3 because it's your left-right direction. So that's how you can tell. So wherever these half angles fall, that's what your sine is going to be. Now, for tangent, you don't have to worry about quadrants of sines. They actually work themselves out in the equations. So the tangent of the half angle is equal to either, you can use either a formula, 1 minus cosine u, so cosine of the original angle all over sine u, or sine u over 1 plus cosine u. So you can use either one, it doesn't matter. So why do you even need half angle formulas? Well, let's take, for example, you're trying to find the sine of 15. Well, 15, as we know it, is not on the unit circle. But if we double that angle to 30, we know we can find the angle 30 on the unit circle. So I'm going to rewrite 15 degrees as 30 over 2 or 30 halves, and then I can use the angle 30 to evaluate. So let's say you're trying to find the cosine of 75. Again, 75 is not on the unit circle. But if I double that to 150, we know that is on the unit circle. So I can rewrite cosine of 75 as cosine of 150 over 2. And then tangent, let's look at a tangent situation. You've got 165. Again, that's not on the unit circle, but if we take that and we double it, we get 330 degrees. And we know 330 is one of the values on the unit circle. So all you're doing is rewriting the angle in relation to a value on the unit circle. Okay, so let's try a couple. Let's start with the sine of 15. So using half angles, we're going to rewrite the angle as 30 over 2. So we're using the angle 30 to evaluate. So here is our sine of a half angle. Sine of the half angle is equal to positive or negative, and we're going to take 1 minus cosine of u, which is 30 degrees, all over 2. Well, we know cosine of 30, we can evaluate that. That's on the unit circle and this very first position. That cosine is positive square root of 3 over 2, all over 2. And all this is still under the radical. So now let's just kind of clean this up. Okay, 1 we can rewrite as a common denominator with 2. So we're going to rewrite the numerator as 2 minus the square root of 3 all over 2. Okay, and that's going to be 2 minus root 3 on top. On bottom we have 2 times the reciprocal of 2, which is 1/2. And again, this is all under the radical. So what have I got left? I have 2 minus root 3 all over 4, all under a radical. Now, what's nice about this is because we multiply these 2's together, I can now bring that 2 out, and I just have 2 minus the square root of 3 all under the radical on top, all over 2. So there's the value for the sine of 15. Now, I did kind of skip a step, so let's go back and talk about it. Okay, this could be a positive or a negative. So what we want to do is we want to look at the angle 15. 15 we know is in quadrant 1. So it's between 0 and 90. It's right here. It's half of 30. It's right there. And we know sine is indeed positive in that quadrant. So our final answer, when we went to simplify this, it's a positive. I'm not going to write it, but that's how we decide to use the positive or negative outside the radical. So let's look at cosine of 105 degrees. We know that value is not on the unit circle. So let's rewrite this as the cosine of an angle that is on the unit circle. So if I take 105 and I double it, I get 210. 210 all over 2. Now this is a good one to look at because we can now consider sine, S-I-G-N, the sign of the value. So I have a positive or a negative square root of 1 plus cosine. Theta in this case is 210 all over 2. Now let's go ahead and decide on the sign of the answer. Okay, cosine of 105. We have to look at the original angle. So what quadrant will that fall into? It falls between 90 and 180, so it's falling into quadrant 2. So cosine in quadrant 2 is negative. So that means our final answer, we have to drag along a negative with us. Okay, so this is negative square root. Let's go ahead and evaluate cosine at 210. So cosine at 210 is going to be, let's see, here's 180. And 210 is going to fall right here. Well, that's going to be a negative square root of 3 all over 2 all over this value 2. So I'm going to bring that down that 2. So now let's simplify some of these. So we've got a negative, and in the numerator, I'm going to change the 1 to a 2 over 2 minus, I'm just going to make this a minus right here, square root of 3 over 2 all over square root of 2. Now notice I separated those, and that's fine. So I have a negative on top, 2 minus square root 3, all under the radical, all over the square root of 2. And then if you change flip, okay, I'm going to multiply the top by 1 over the square root of 2. Oops, I dropped my 2 here, didn't I? Let me bring this over. Sorry about that. There is a 2 in that denominator, all under this radical. So that means I'm going to multiply this by 1 over the square root of 2. Well, square root of 2 times the square root of 2 is just 2. And in my numerator, I have a negative, remember, because it's negative, square root of 2 minus the radical 3 underneath. And there's my final answer. Okay? And that's how you evaluate all these half angle formulas. So we've done a sine, we've done a cosine, so let's try a tangent. Okay? So we're going to take the tangent of 5 pi twelfths. Well, 5 pi twelfths is not on the unit circle. So let's take that and multiply it by 2 to find the angle we want to use the half angle formula with. So if you multiply that by 2, you are going to get 5 pi 6. So I'm going to rewrite 5 pi twelfths as 5 pi 6 all over 2. Now, let's plug it into our equation. So do we want to use the first one or the second one? I'm going to use the second one. I'm going to use 1 minus cosine. Okay, we rewrote the angle on top as 5 pi 6 all over sine of 5 pi 6. So this one's a little bit different because we're evaluating both sine and cosine. So let's simplify that. We've got 1 minus, well, 5 pi 6. Let's think about that position. That falls right here at 5 pi 6. So cosine is a negative square root of 3 all over 2. Sine of 5 pi 6 is positive 1/2. So I'm going to have a half in my denominator. Now we need to do a little cleaning up here. So I'm going to change this 1 to a 2 over 2, okay? So I can combine my numerators. 2 plus root 3 all over 2 all over 1/2. And then I'm going to change, flip. So I'm going to multiply by top and bottom by 2. Boom, boom. And what happens is I just get 2 plus the square root of 3. And there's our final answer. So that's how we're going to find that one. Okay? Tangent of 5 pi 12ths is 2 plus the square root of 3. Now let's talk about the SIGN, or the sign, if it's positive or negative. Okay, in this case, the sign is positive. So let's go back and look. 5 pi 12ths. Well, 5 pi 12ths is going to fall into quadrant 1 because 6 pi 12ths is pi halves, right? And that's, we know, at 90 degrees. So 5 pi 12ths has to be in quadrant 1, and everything in quadrant 1 is positive anyway. So the nice thing about tangent, sorry, it keeps scooting down. The nice thing about tangent is you don't have to worry about figuring out your sign being positive or negative. It just works itself out in the equation. So our final answer is 2 plus the square root of 3. And it's a little bit easier because we don't have those double radicals. Okay, and that's how you evaluate half-angle formulas. Now let's look at a solve using half-angle formulas. So let's say we're going to find all the solutions of 1 plus cosine squared x is equal to 2 cosine squared x over 2 on the interval 0 to 2 pi. Well, this equation is kind of nice in that they're both in terms of cosine. But this one is a single angle and this is a half angle. Well, we can't combine those because the angles are different. They're not like terms. So what I can do is I can take my half angle formula and I can replace it with this one, the cosine. So now the catch is this is squared and this one's not. So that means I get to take this half angle formula and square it. Well, that's nice because I don't have to worry about my positive and negative because they're going to get squared, and I get rid of my radical all at one time. So I'm going to plug in 1 plus cosine squared. So there's my left side. I'm just bringing it down. And then I'm going to have 2 times my half angle formula, which is plus or minus the square root of 1 plus cosine squared theta all over 2. And then this square means I'm going to square that formula. That's when I get rid of my plus and minus, and that's when I get rid of my radical. So I'm going to have 1 plus cosine squared x equals 2 times, let's see, if I square all this, I get rid of the radical, so what's left just comes out, and I have 1 plus cosine theta all over 2. Okay, so far it looks pretty good. Now I can cancel my 2's out because 2 and a half, they just cancel. So now I have 1 plus of cosine squared x equals 1 plus cosine x. Okay, now you can see a little bit of an issue. This one has a square and this one doesn't. Not a big deal. I can just factor that then. Okay, the ones cancel off of both sides. So I get cosine squared x. I'm going to go ahead and move this other cosine over because you can't divide by a trig function. That's getting rid of solutions. So I'm just going to bring my cosine over and get it set equal to 1 or to 0. Then I'm going to factor out my common factor. My common factor is cosine. So let's take out a cosine, and what are we left with? We're left with cosine x minus 1 equals 0. So now that we have it factored, set both factors equal to 0. So cosine, where is cosine x equal to 0? Well, cosine x is equal to 0 where x is pi halves and 3 pi halves. And let's look where cosine x minus 1 equals 0. And that's where cosine x equals positive 1. And we know that that is where x is 0. You could say 2 pi, but we're just looking on the interval 0 to 2 pi, not including 2 pi. So it's just going to be 0. So this one has 3 solutions. Pi halves, 3 pi halves, and x is 0. So that's how you solve the first one. Now let's look at solving this one. Find all solutions of cosine squared is equal to sine squared x over 2. So we have a half angle formula. So we're going to replace this half angle with the sines formula. Again, we're going to square it, which is kind of nice because then we get rid of some positives and negatives that we don't have to worry about. So we want to get these angles to match, and that's why we have to use that half angle formula to do it. So we're going to do plus or minus the square root, and the sine formula is 1 minus cosine x all over 2. And we're going to take that and we're squaring it because of this square. Okay, now, once we square that, we're going to get cosine squared x on the left, and on the right, the positive and negative cancel out because we're squaring them. It doesn't matter. The radical disappears, and we have 1 minus cosine x all over 2. Now we need to solve this one. So let's multiply both sides by 2. So we get 2 cosine squared x equals 1 minus cosine x. We want to get everything to the same side. This one's going to end up being a trinomial. So we have cosine squared x, or 2 cosine squared x, plus cosine x minus 1 equals 0. Now let's factor this trinomial. So we're going to factor that into, let's see, the first term is 2 cosine x. So that means this must be cosine x because they multiply to 2 cosine squared x. We need a 1 in the back, but one's positive and one's a negative. We know we have a 1 here and a 1 here. We need the larger one to be positive, so the outer would be positive 2x, the inner would be negative 1x to get our positive x, and that's how it's going to factor. Now let's set each factor equal to 0. So where does 2 cosine x minus 1 equals 0? It's where 2 cosine x equals 1, which is where cosine equals a half. I'm just going to go ahead and divide by 2. So where is cosine at positive 1/2 on the interval 0 to 2 pi? Well, that's at pi thirds and 5 pi thirds. And let's look at where cosine x plus 1 equals 0. That's where cosine x is equal to -1, and we know that that's at pi. So we have three solutions. X is pi, pi thirds, and 5 pi thirds. So that one has three good solutions. And that's how you solve using half angle formulas. You're going to substitute and just evaluate. So I hope this video was helpful on going through not just solving, but also how to evaluate sine, cosine, and tangent formulas using the half angle. Okay, just a last minute reminder. Remember to use the original angle to decide if sine and cosine are positive and negative. It's not the angle you plug into the formula right here. It's the original angle beside the quadrant. So I hope this video was helpful, and thank you for watching.